Here we need to know where the function is concave upward and where the function is concave downward. Concave upward, that's when the second derivative is greater than 0. Concave downward, when the second derivative is less than 0. Now, to take the derivative here, I got to do the first derivative first, which I have to use the quotient rule. It's the bottom times the derivative of the top, which is what? 2x plus the top, which is x squared times the derivative of the bottom, which is 2x. Oh, minus, not a plus, right? It's the bottom times the derivative of the top minus the top times the derivative of the bottom. The whole thing divided by the bottom squared. The good news is x squared times 2x, it will cancel x squared times 2x on that end. So you're going to end up, if you simplify this, is 18x over x squared plus 9. That's your first derivative. I'll verify that quickly. Escape, wait 1 second, clear, exit, quit. Okay.
It's supposed to be squared.
X squared plus 9 squared, yes. God, they're making so much noise next door.
Musical chairs. Yeah, they're doing it just to upset you.
They're done. They're leaving. I don't know how the hell they can be that done. It's Calc 2. Okay. I can't see what it says. Is mouse here home or home? Okay, here we go. So let me just make sure this is correct. The derivative of x squared, where'd you go? Divided by x squared plus 9 18x, here we go. The derivative x squared over x squared plus 9 is 18x over x squared plus 9 squared. So now let me take the second derivative. Again, I can use actually the quotient rule again. Times the derivative 18x, which is what? 18 minus the top, which is 18x, times the derivative of the bottom, which is 2 times x squared plus 9 to what power? 1 times the derivative what's on the inside, which is what? 2x. The whole thing divided by the bottom squared. And you can see from the top I can pull out x squared plus 9 out. If I pull 1 out, what's left? In the first group I have 18 left and I have x squared plus 9. In the second group I'm going to have 2x times 2, which is what? 4x, so it's 18x times 4x. That will cancel one of these. That will leave me with 18 times x squared plus 9 minus 18x times 4x over x squared plus 9 to the third. And I'll speed up the process here. Where's the comma here? And the answer, according to this, factor everything out, negative 54 times x squared minus 3 over x squared plus 9 to the third power. So that's my second derivative. Now I got to find out where the derivative is 0, where the derivative is undefined. The second derivative. So take the second derivative and set it equal to 0. Take the second derivative and see where it's undefined. Second derivative to be 0, that means the top of that fraction has to be 0. Which means x squared has to equal 3, and x will have to be what? Plus or minus the square root of 3. For the derivative to be undefined, that means the bottom of the fraction has to equal to 0. Which means x squared will have to be negative 9. Does not exist, or no real solution. You can't have something squared be a negative number, not a real solution. So it has to be a fake one. Imaginary. So my second derivative, I don't care about the first derivative now, I'll make my box here just like the first derivative. I'm looking at the second derivative. I'm going to cut it into two parts. So the first one is negative infinity. Infinity, we're going to cut it to negative the square root of 3, positive the square root of 3. Square root of 3 is 1.7, so maybe I'll take a negative 2 here. I'll take a 0, I'll take a 2 for a test point. And plug it into the second derivative. Again, there's my second derivative. Here's the good news. Let's look at this before you even do any math. When you take a number and you square it, that's the bottom, I'm looking at the bottom, x squared, it's going to be what? Positive or 0. When you add 9 to it, the result is what?
Always positive.
Always positive. Cube it, the bottom is always positive. I don't even have to waste my time on it. That bottom will always be positive. So I'm only going to look at the top. I already have a negative in the front. When I use the negative 2, what's negative 2 when you square it? Positive 4 minus 3, that's a positive. Negative times positive over positive, that's what? Negative. Concave downward. Let's try the second derivative at 0. This was at negative 2 here. I was testing the negative 2. The bottom is always positive. This is a negative here. When it's 0, what is 0 squared? 0 minus 3, that's a negative value. Negative times negative, positive over positive, that's a positive. Concave, upward, downward. And let's take the 2 negative, positive, over positive, the result is negative. Downward. So now we know it's concave downward, here and here, concave upward right there. So downward from negative infinity to negative the square root of 3. Don't forget to add to it from the square root of 3 to infinity. Upward from negative the square root of 3 to positive square root of 3. That was number 6. Y equals 6a. Huh?
Don't need. I don't.
Oh, you don't need it?
Yeah.
Okay. So skip 10. I like the skipping. So now we go to 17. There was a double on 17, so 2 people on that one. F of x equals 3 sine of x plus sine 2x. You really have an option. You can take sine 2x right now. Eventually you're going to do it, either now or later. If you look on the board, one of my trig identity, number 15 on the board, it says sine 2x can be written as what? 2 times sine of x times cosine of x. That's double the angle. So I'm either going to do it now or later. I'll wait till later. Let me take the first derivative. Derivative sine is what? Cosine x. There's the plus. What's the derivative of sine 2x? Cosine 2x times the derivative 2x, which is what? 2. This is my first derivative. My second derivative now, because I need the second derivative. Derivative cosine x is what? Negative sine of x. This will be a minus. 2 times 2, 4 sine 2x. And now we have to take the second derivative, set it equal to 0. It can't be undefined because there's no fraction. The sine will never be undefined. Tangent could be undefined. It's tangent sine over cosine. So when the cosine is 0, the tangent is undefined. This will never be. So negative 3 sine of x minus 4 sine of 2x equals to 0. Are we good so far? Was there a question? Somebody had a question on it? Now I'm going to take the sine 2x, replace it with this, because they have to match. So sine 2x, I'm going to put in place of it 2 sine x cosine x. and find out when this is going to be 0. You can factor sine of x out. Negative 3 minus 8 cosine of x. Now you're multiplying two things, your answer is 0. The only way that will happen if one of them is 0. Or, let's see, minus 3 minus 8 cosine x equals 0. Negative 3 equals 8 cosine of x. Cosine of x equals negative 3 over 8. I think it's negative 0.375. I think. Let me see if that number is correct. Is it? Okay. So let me find what x is. Between 0 and 2 pi.
Is that closed or open interval?
That's actually a closed interval for that one. They gave us 0 to 2 pi.
Okay. So 0 and pi.
0. When is the sign going to be 0? It looks like when x equals what? 0 and pi. The cosine is negative. To get x, that's the inverse cosine. So let me go to my calculator, because I don't have that 0.375 on the unit circle. So I go second, or turn it on first, inverse cosine of negative 0.375. 1.96 radian. Round answer to 3 decimal places. So here we go. 1.955. That's 3 decimal places. That's only one of them. There's another one. What's the other one? Let's see if you remember. My students will know. I used to say, or you probably heard somebody saying, all students take calculus. Or we say, all stores take cash. That's what I like. When I teach tech math, not everyone take calculus. All students try chicken. Whatever you want it to be. All students take calculus. I'm on video, I gotta make it clean. So if you think anything bad, we don't want to hear it. The cosine, that all 3 are positive here. The sine is positive here. Cosine is negative. Tangent is negative. T, the tangent is positive here, which means the sine is negative. The cosine is negative. C for cosine, the cosine is positive, which means the sine is negative, the tangent is negative. So that tells you which function is positive in each quadrant. S for sine, T for tangent, C for cosine. All 3 are positive. So we got 1.955. Is that more than pi over 2? Bet you that's in the first quadrant. What is pi over 2? Oh, that's a negative value. I'm sorry, that's a negative value, right? The cosine is negative. So it's in this quadrant. What you're seeing is 1 in this quadrant. So you have an angle here. This is one of the angles you just gave me. This angle, when you measure it this way, that was 1.955. Well, there's another angle. The cosine is negative in this quadrant and this quadrant. If you take this paper and fold it along the x-axis, you'll see there's an imprint right there, straight down. So there is 1 down here when you fold that paper. If this actually wet paint, will be a smudge there. And the smudge will be right here. And what is this value now? I need to read that value. How big is that value? Well, if the value from here to there is 1.95, that means this value here is also what? 1.95. 1.955. but that'll be a negative value. We wouldn't want to use negative because this one says use positive number between 0 and 2 pi. So to get the other number, a full circle is 2 pi. 2 pi take away 1.955. So let's see what that number, 2 pi minus that number, 1.955. And it's 4.328. I'm clearing all the digits. So the other number here is 4.328 if you carry all the digits.
What's a good way to remember that you have to find that second angle?
Huh?
What's a good way to remember?
2 pi minus that value.
No, what's a good way to remember?
I don't have a saying for that.
You have to do it?
Just fold the paper in half, just try to visualize it.
To remember, to even do that in the first place, so I'm saying, like, how do you not forget that what you get in your first angle, you get to find a second?
The sine, cosine, tangent, most of them always have two, most of them. Two, I said most of them. The reason I said most, not all of them, because if, for example, where's the paper I was writing? If the value is right here, if this number was this one, when you fold that paper, you're not going to get a second number, you know? So that's why, but usually there's, if you look at the unit circle, when the sign is positive, it's always two values, one here and one down here. I mean here and here. The cosine is positive or negative, here and here. Notice this number, there's a matching one right here.
We haven't had to do an inverse cosine yet, so I...
Yep. So now we get four values to break that. I'll make a new sheet for that. That's just addition, like a review for those people. 0 here, 2 pi, and I'm going to break it down to 4 pieces for the second derivative. The first value, well, the one cut at pi here. Pi is what? 3.14? So that's somewhere here. Pi, 3.14. I have 1.955. And I have 4.328. So I'll take a test point. I'll use a 1. I'll use a 2. 3.14, 4.3. I'll use a 4. How about use a 5 here? And let's go to the second derivative and plug them in. And let me cheat here. I'm going to pretend I'm going to graph this, but I'm not really going to graph it. I'm going to go to the table here. -3, I'm showing you how I'm cheating here. Sine of x minus 4 sine 2x. I'm pretending I'm going to graph it, but I'm not going to graph it. I'm done with it. So I'm good. Let me make sure mode, I am in radian mode. Yep, I'm in radian mode. Let me go to table and set my table up. Table set, that's second table set. Make sure I'm in ask mode, which is I am. I want to be in the ask mode, not automatic. The independent one, I want to be in ask. The dependent, I want to be automatic. I don't want you to ask me for the answer. I want you to do the answer for me. The independent, that's x. The dependent is f. So I want the x to be any value I want to put in, but I want the value for f to be calculated automatically for me. So that's what that setting is telling me. Now let me go to the table, and let me find the derivative at 1. So I just put a 1 there for x, and it gives me the answer. It says negative 6.162. You can do it by hand slowly, but that's what you're going to have. Concave downward. What's the second derivative at 2? Positive 0.299. That's positive. Concave upward. What is the second derivative at 4? At 4, negative 1.687. That's a negative. Downward. And what's the second derivative at 5? At 5, it's 5.053. And that's a positive. Oops. That's concave upward. So downward, I see it from 0 to 1.955. There went 3 decimal places. And excuse me, from pi to 4.328. Upward, from 1.955 to pi, add to it from 4.328 to 2 pi. And that's where the function is concave upward and concave downward. Now, if you want to find the inflection points, where's the inflection point? This is 1, this is 2, this is 3. Inflection point, that's where the function changes concavity. We have one at 1.955, but they also want the y value. We'll come back and get the y value. We have one at pi, and we have one at 4.328. And get the y value for them. Now, to get the y value, you need to go back to the original problem. So here we go. Clear this one and type the original problem. 3 times sine of x plus sine 2x. That's the original problem. Now go to a table and let's put some numbers. When x is 1.955, what is the y value? 2.086. When x is pi, they probably want you to write 3.14, whatever pi is. I'll just use pi here. When x is pi, 3.1416, the y value is 0. When x is 4.328, what is the y value? Negative 2.086. So these are my inflection points. Again, the only thing, you probably have to write pi as 3.124, whatever that number is. 3.146 something. What is pi? $3.142. So in place of pi, you might have to write 3.142. You know, because there only is 3 decimal places and 0. The largest value, the smallest value. That's the smallest for x. I'm assuming for x. Smallest x value, largest x value. Yep. That's the smallest x value. That's the largest x value. That's the middle x value. 3 values.